Right, you be, it's Boots Owen here, back again. I've got a Triton t300si shower. It's a bit of a mixed bag because I replaced this part, so this is a second-hand unit, but all the other bits are brand new. It was cheaper to buy all the bits than to swap out the power unit. But I wanted to have a look at it today because it's a bit of a bizarre one. It's a electric shower, but it's a remote electric shower. So in the bathroom, you have this thing, which is just a control panel that fits on the wall, and then you have a little kind of bulkhead thing, which is just basically like a bathroom tap kind of thing. It's in that. I'm not going to open it. It's just basically an elbow that comes out of the wall that you attach the shower hose to, and so you've got a standard shower hose and standard shower head and all that kind of stuff, which is all still new because pointlessly I ended up buying the thing for the thing. But what's a bit kind of fun about this is that from here to here, you've got this cable. It's just a normal kind of data cable, like a LAN cable or something like that, but it's got a special sheathing on it, so obviously it costs 100 times more. So you've got that cable there. You've got a couple of different pieces of hose pipe. So you've got this heated water hose, which is just a piece of some kind of plastic, kind of rigid. And then you've got this piece of soft plastic pipe, PRD tube, which is the pressure blow-off tube for the, goes on in here, lets out, just see that little nozzle in there at the bottom, lets out any, there's some water coming out of the element, lets out any kind of, if the shower pressure builds up too much, it shoots out that way. So what am I looking at here? Well, I'd never seen one of these before, so I thought it was kind of cool, but also the mechanism of failure, why it broke, is a bit weird. So what happened was, if you were in the bathroom, typically if you had it up to 10 on high, it would be extra hot, steamy, scaldy hot water, and so you'd run it around that kind of 6 or 7. But what happened was, on the high amount, and pretty much on all of them I guess, there was no difference when you turned this knob. So either it was a thingy that sends the signal from in here, which I presume is just some kind of not a rheostat, what's that thing called? Potentiometer. It might be a potentiometer. In here it sends the signal down through the data cable over to here, and there's a little telephone kind of socket there, or a socket there, where the stuff goes in, and then it just tells this what to do remotely from over here, which is in the bathroom. So you're meant to put this in the hot press or in the loft or somewhere adjacent to the bathroom. You've got about 3 or 4 meters of hose, so somewhere that far away on the other side of the wall basically, so this isn't in the shower with you, which I think is a great idea, because electric showers, as I've made a video before about a red ring shower, which I thought was a bit of a nightmare, generally speaking, in the shower you can always touch this unit. In here you've got potentially, I think this one is a 8.5 kilowatt unit, but you can get them up to like over 10 kilowatts. 10 kilowatts of electricity around face height, with water flowing through it at mains pressure, right beside, like really, it's just a kettle that the water flows through. So the water flows in here, in here, up through here. This is the regulator that lets the water amount through, and more water means that the water goes through quicker and it doesn't get as hot. So what this does is it, on a regular shower, on a regular electric shower, you just have the knob here, but this one has this servo motor stuck on the front. It's driven from this control board, so we'll talk about all that stuff later. But basically, more water means cooler water coming through because there's more water going over the element in the same space of time. And then the water comes out here, and on this one goes through a long hose to the spigot on the wall, or the bulkhead on the wall, and then just comes out through the shower head. So something's gone wrong in here. It could be the potentiometer, if that's what is in here, or it could be some of the electronics, of course. It could be this motor, but what's more likely is that there's just a little valve in here that's knackered. And to do all of the fault finding and all of the chasing, it's basically simpler just to replace this and then it's done. Unless you've got a load of free time. But the other reason, once I had this opened up to look for the part number on the side there with the power rating, if you have a closer look, this yellow crimp connector here kind of suggests that this has broken in the past and someone has been in there, because that looks like a post-manufacturing service part that someone's just made up on the fly. And then if you look over here, I'm going to have trouble to see this now, let's get a closer look in here. So the power cable that comes in, you can see that there, it's lovely and shiny. It's completely blackened, that cable. So from about here down to the element, it's blackened. So that's overheated, and the insulation's breaking down on it, which, you know, for a remote shower, it's not exactly dangerous, and it's on a system with the trip switch and all that kind of thing. So you've got a circuit breaker and a residual current device. So there's no real issue getting electrocuted, I don't think. But we've also got scorch marks in here. So there's a little contactor, little low voltage contactor there to make a connection in here. You can see that it's like a little solenoid with a contactor on the end of it. We get a close up on that. Yeah, so they're all the same, those three white things there. This one's a good one, looks clean. This one, it's all burnt, and the connector above it's all scorched. So there's a few reasons why it's kind of a better idea just to get rid of this. You see this water still dribbling out of it because it's just been, that's why I've got this rag on the workbench. So what's going on here then? Well, so the water's coming in here just from the mains. It's got a valve here, exactly the same as a washing machine valve, 220 volts. And that lets the water go in and up into this white thing here, underneath this servo motor. And there's a valve in there that, like a regulator, to let more or less water in, and it goes in through here. And there's two different elements, an economy and a high. Economy just means low, basically. Two kettle elements in there, up to about, what would they be, 8.5. So they're probably roughly 4.5 kilowatts each, something like that. Could be a different step, could be like 6 and 2 or something like that. But anyways, water goes through there and comes out the bottom, and there's a little temperature sensor here, probably just for overheating. And then up on top there's another safety temperature sensor on top of the unit. In terms of electricity, what's going on? Well, you've got your earthing and you've got your live and your neutral in. Neutral goes straight over to the elements, and there's another neutral coming off then going to this transformer, and likewise there's a live coming off here going to the transformer, and the transformer gives these two red cables to give you power for the circuit board, which will be a lower voltage transformed down to drive the circuit board. You've got the data cable here going over to the control unit, and then that's a back and forth system. But basically what it does is, if you turn the knob on here, the potentiometer tells the board to turn the motor here to do that. That's really all there is. So there's a lot that you can select the different elements, and these buttons here then drive those little contactors, little solenoid switches, and they put enough electricity into the right elements at the right time for when you want it. So you've either got cold, which means no power to this, just runs cold water through it as a non-pumped, it's not pumped electric shower, it's just an electric shower, so it just lets the water through, and you can regulate the speed of the water going through it with this still from over here, and then you can add one element or two elements in this little kettle, and that's about it. They're pretty simple things. I guess the electronics are going to be a bit fancier. But I just want to break this down and see if what's in here is broken. So I'll do that now. So that's the motor there. It's a Sala Burgess 325. It's got a UDB 2NO 2D16 AAN5JZ17. It's a little motor, just a little motor running off, what'll that be, 12 volt or 5 volt, whatever is coming through the circuit board there, and it's got a little gearbox on the bottom of it by the looks of things to step the motorness down. So we could test this by firing it up, but the problem is we got to put a 10 kilowatt supply in, I guess. We could probably try running it on eco only, but yeah, I might just do that for fun to see what happens. Then in here, this is where the pressure regulator is. Let's just have a look. Might be difficult to get in here. Sometimes these things are easy and sometimes they're not. Looks like there's only one screw holding that on, but we'll need to get this off to get in there. I'm expecting this will have water in it, because they typically do. So normally these just have O-ring seals between all of them, so when you're taking them apart you just have to check the O-rings in position. So that's your inlet switch valve, inlet valve, just like a washing machine. And this one here, so we probably have to loosen off this element which is held on over here. And at the bottom. That lifts that up, that pulls out, that's got water in it, making a mess. I lost an O-ring there, so I'm presuming that O-ring just sits on here. So if the servo motor had gone, to replace that was about 130 quid, and if this piece here had gone, it was about 20 quid. Now, there's a clip hanging in space in there, which shouldn't be there. First of all, so that shouldn't be there. So that's a clue. A clue to what? A clue to what? A little E-clip that snaps onto the end of a shaft usually. A shaft like that maybe? Hard to say. So what's going on there? Water comes in from the bottom, because that's the front of it. So water comes in that way and goes out that way, and this somehow slows it down, so it's coming in under here and going out through here. But that little clip would come out. So it seems pretty obvious then, if there's something loose and missing in something, then this is the bit that's gone. And these aren't that dear, these are about 20 quid or something on eBay. They're pretty chintzy plastic really, they're not great. You can see a load of the scrapey marks there from where that was, the mold of that was machined out, but like, it does what it does. How am I going to get in here? Right. Like, I wonder if that was meant to be on the end of this shaft. It could be. It's about the right size for that. But if it is, it's fallen off. If it's fallen off, it might have clogged it somehow. That looks like some kind of an emergency. Well, no, it shouldn't be, because it would just blow out water onto the circuit board, which would be pretty stupid. So let's have a look in here as well. Yeah, it is some kind of a pressure blow-offy thing. Bit of crud in there. Look in there. So how's this working? Diaphragm seems okay. The rubber's not broken. That is another part that's a service part on this. You can get a service kit to redo it. Okay, so the water comes up and around there. Look how small the holes are, really. Really small. Let's get a sharp knife on it to wreck it. Okay. So that's got an O-ring seal inside it. looks like we need. Okay, that pulls off there. It's bizarre. I wonder if that's worn out or what, but that would rotate within here. Ooh, there's something else in there as well. Some other little piece of plastic that I didn't notice before. So has that popped off the end of that shaft? So if that was on the end of this, which this is starting to look like it makes sense, that looks like it was meant to be on the end of that shaft there, like this, with this clip around it, holding this thing onto the shaft. And it looks like these two bits have popped off. And means it's broken. It's broken. Now, what's going on in there? Yeah, the end of that shaft looks like that bit of plastic is broken off. So we've got an O-ring and we've got something else in there. Not entirely clear on how this works. What would turning this do? Because you're turning it through normally quite a distance. It doesn't look like it would bring anything in or out. This being in here, there's no spiral shaft or anything. Unless just by turning it that tiny bit changes the amount of pressure on the water, or changes the friction on this if it was spinning around. That's a cone shape in there. And there's some little marks on the inside. See? So I wonder if there was something in there that this is broken. I don't think I'm going to get to the bottom of it. The way those bits in the bottom looks like it snaps into place. But I'd say this is the culprit for why this shower broke, regardless of the scorched out cables on top. So we've been in, I'll put it back together, but that's pretty much the gist of it. So a remote controlled T300si Triton shower. It's a pretty cool piece of kit. It's not exactly high-tech, but it does have the level of a servo motor onto the front of it. Servo motor, stepper motor. I wonder, is it a stepper motor? Could be. In fact, it probably is, because there's no limit switches on it or anything like that, so it's just pushing it a certain amount each time. Don't know. Someone else might tell me about that in the comments, because I don't know much about these things, as usual. The other thing is the water flowing through there could be doing something, could it? So that pushes on down there like that. And then this little piece of plastic and this little clip would have stopped it popping off, and then this goes in there like that. And then this goes on the top, but this bit, which one is that, like that? Not that one, this one. This one sits on top like that. What does it do at all, eh? It's a mystery. Water, eh? Magic. Magic stuff. I'll put it all back together. Let's unwrap a bit of this special data cable. Easy for big fingers, huh? Right. 5 amps should be enough to drive the transformer and that motor. On. Don't touch the metal. Put that there, turn that on. Woo. Anything? We're not live yet, of course. Okay, so that's that. That's the neutral side. Put that in there on the safety block. Let's put this one over here. No earth. Happy days. Boom! Anything? Yeah. Got a red light over here. So now it's cycling through. You can see these little lights cycling along. This data cable seems to be a bit fiddly where it is. So let's put that So it does this 30-second thing, and then it goes off, I guess, or else it's stuck on. No, it's just that thing's not in the right place. So if I press, oh, it's doing it. It's doing it. What's it doing? It's cycling through the lights, and it's doing this startup check that it does each time. Sounds like that was a servo motor just doing some kind of a feedback thing. So if I press start, it can't do anything because there's no water in it. Could overheat and blow up. Don't think it will. Yeah, tripped the switch straight away. So why would that be? Overload of power trying to come through to here. Maybe. Don't know. It's never going to be safe anyway. It's never going to work off this because it's only 5 amps rather than what would be 40 amps. I don't know if I want to test this any further. Yeah, too much hassle. Alright, there's a bit of a description of this thing. That's all off. Let's turn that off as well just in case. Plug this out. Start putting this away. So thanks for watching this video about this Triton T300si electric shower and a bit of the stuff that was wrong with this one, and a bit of a look at this little setup that I've created. If you like this video, hit it with a thumbs up. If you think it's crap, hit it with a thumbs down. If you want to see other videos, check out the playlist that this video is in. There should be a link coming up sometime soon, and then otherwise just check out my other videos on my channel. There's loads of 400 or odd other videos in there that may or may not be worth looking at. But this shower, it's probably better than a regular electric shower in that the power isn't going straight past your face, but it only pushes the power a little bit further away, but it's quite unlikely to electrocute you, which I think is quite good. This one, why it died? Well, I've had a look at that. There's some mysterious parts floating around inside in that pressure regulator, and then some scorching of the cables and some scorching above that little contactor there. That's why this one seems to have failed. Probably just those little parts. Thanks for watching. See you later.